Hey man, you ready to call the... Whoa, I am so sorry, man.
Come on in, man.
Oh, jeez.
Doing an episode on numbers, just practicing my counting.
It looks like you're doing something else. Why don't you have pants on?
Because I'm counting to 11.
More like 10.2. Let's get to it.
How hard this was to research and try and sound as human like I was doing work.
Our next guest is a lover of maths and a complete numberphile.
Yep.
If he's not writing books, he's hosting morning breakfast shows, doing stand-up comedy, or making top-rated podcasts.
Oh, yeah. This one.
His latest book, The Number Games, has had much praise from notable people such as John Cleese, Will Anderson, and Russell Rusty Crowe. Adam Spencer, welcome to Sci-gasm Podcast.
Lovely to be here, boys. Let's clarify a couple of things on the introduction. John Cleese is Cleese, as in rhymes with cheese. He told me that personally when I worked with him a few years ago. And I'll be honest with you, he's not read the book. He gave me a quote from a first book, the Big Book of Numbers. He was lucky, good enough to do that. He was in Australia at the time, writing his own memoir, I think called But Seriously or something, that came out a few years ago that's meant to be great, that I haven't read, I must admit. There's no quote from the front cover of it. And I sent him a link to my book and said I really need any chance you could give a quote. He got back and said, I'm incredibly busy. I've had a quick look at it. It looks great. Here's the quote. So he's skimmed the first... He hasn't read everything in the first book. I'd be very surprised if he's read The Number Games.
You are far too honest.
That's very modest. And he's also... Adam Spencer, he's also very modest.
And Will Anderson, again, I can't vouch for Will having read the entirety of all four of my books. Though you might be... surprised at how much Will would understand if he did read it. He's
really?
A little bit cluier than he lets on sometimes, the old Will.
I have to say the most impressive thing I've seen of Will Anderson is his right arm size compared to his left arm. I was watching a stand-up show and his right arm is massive. He was talking
What
about...
are you insinuating?
No, it's what he was insinuating during the the stand-up. It was...
He's a tennis player.
There you go.
Oh, is he? There you go.
The other one is your...
Russell Rusty Crowe.
No, sorry, I'm talking your other sporting asymmetry. I think it's your speed skaters who have the most asymmetric body because of the completely different size of their legs from the leg. I think they all speed skate, anti-clockwise.
Yeah.
That's my memory of Stephen Bradbury coming around at the end.
That's exactly what I was using too.
So from everyone leaning in like that, I think the left thigh takes a lot more of the load and is a lot chunkier. And the right thigh a little bit more svelte.
I have to admit, that was the excuse I gave to the nun during my time at Catholic high school, as I was doing push-ups all with my right arm.
All right, can we get into this interview? God.
Sure, why not?
This took a very quick turn south.
It's going to be great.
Oh.
Okay, so firstly, why maths? What is it about the subject that inspires you to devote so much time to promoting it?
I think the essence of being human is to look at the world around you and ask what's going on. It's the most fundamental thing that separates us from dogs and mosquitoes is we spend more time contemplating the universe than they do. And of all the different devices we have to examine, explore, predict, describe, contemplate the universe, I think over time numbers have proven to be the greatest of all of them. Better than words, better than art, better than anything else. Numbers are the way to understand.
What about when they start chucking letters into numbers, though, in algebra and calculus?
Yeah, how awesome is that, you see? You don't ever go chucking numbers into the alphabet, do you? No,
that's true.
But all these letters want to be part of maths, don't they? Yeah, the numbers are quite busy enough as it is. You don't find numbers going and inserting themselves. Well, they do. The only time you really find numbers inserting themselves is in novelty number plates. So if you wanted to have the number plate number, you'd have NUMB 3. for example. So I guess there is that count. There's always a counter.
Maybe some text messages. CUL8.
Sure. Yeah, I think we've moved beyond that.
Yeah.
I don't know if
is that a bit early 2000s? You think?
Yeah, I think you might have dated
showing
yourself
my
there
age here.
slightly.
And so we first officially crossed paths when we were both appearing at Skepticon 2017. And how do you think mathematics can help people become healthy skeptics?
I think mathematics underpins most of the sciences. I think an appreciation of science and scientific method is at the heart of healthy skepticism. And so I think those two things go hand in hand, and I think there's going to be more of that in this century than ever before. This will be the era of mathematical-driven sciences, and big data and analysis and modelling and computer coding. So I think mathematics will play a more crucial role than ever before in shining a light into the corners of ignorance.
So you've touched on that relationship between maths and science. What do you think maths and science are? Are they like besties? Are they siblings? Or do you think they're maybe in like an abusive marriage where science is only interested in maths money?
Well, maths is one of the sciences. So I think I think science is your Sydney Swans, and maths is your Josh Kennedy or Buddy Franklin within the Sydney Swans, like the go-to, preeminent, most important player.
Your marquee.
Within, the marquee player. I see you're wearing your Western Sydney Wanderers shirt there. So ideally we'll finish this podcast without any of the chairs being set on fire or anything. But
I'm assuming you're a Sydney FC fan.
I only back winners.
Yeah.
So I've been a massive Sydney FC fan for about a season and a half now. Now I can name almost all of the players. And so, it's like your marquee player within a salary cap situation, mathematics. And I think you'll find over the next 50 years, you'll be splashing down more and more on your marquee player within your limited salary cap.
Okay, so you're an avid Australian Football League fan, or for our international listeners that we call AFL. And you seem to be really good at convincing people that maths is great. Can you convince me that AFL is a good sport?
Absolutely. I'm not guaranteed that I can, but that's more a reflection on me, you than me, if I can't. Because
I told him not to wear that shirt.
The round ball game too, I don't mind. I coached the University of Sydney women's soccer team for over a decade. Love football in the round ball game. The Matildas putting Norway to the sword 4-3 this morning with a goal on the last kick of the game. And that was in the Algarve Cup or something. Was it played in Norway? It was somewhere. It's somewhere in Europe.
Yeah, it might have been neutral ground. If I think about it, how good are the Matildas going?
I've never heard a crowd make less noise when someone tapped in a 4-3 winner. So I think it's somewhere deep in Europe, possibly Scandinavia. There weren't many Aussies there, and it was you could literally hear the girls on the pitch congratulating each other. Sam Kerr scored for her 7th game in a row. It's an incredible hot streak. So I love the round ball game.
Yeah.
But of your prelate spheroids, AFL is the best of those footballs, I think, by a long way.
Wow.
And mainly because I think your league and your union have struggled, rugby league in particular, has really struggled with the advent of full-time professionalism, incredibly uber-fit athletes on the field. There's just too many guys on the field in a game of rugby league for my liking. And like when I was a kid growing up watching rugby league, and I grew up, loved it, it was rare to see someone score off a kick. It was skill, it was breaking the line, it was getting around. After 50 minutes or so, the big guys were rooted and the little guys could start weaving their magic. Now it's just 80 minutes of 2 rows of 13 gorilla cyborg machines just running into each other. And the physicality of it, if you like watching guys hurt each other, great. But all you can do is get down the other end, then bomb the ball in the air. 6 guys all leap in the air, throw their arms at it. Rugby league has managed to concentrate all the possible controversy in the game on the moment that most matters. You can follow AFL all season. You may well not see a single game where you can honestly say the umpiring cost us that game. Every Monday morning through the rugby league season, there's 3 games. Every Monday, 3 different games on the back of the paper going, it's outrageous, the bunk of those idiots. Well, just try and remove a bit of the controversy from the game. I'm on a high horse here, but I feel very strongly about this. Rugby league, take 2 guys each off each team.
Yeah.
Get rid of the lock and one of the centres.
The sevens is a bit more entertaining, isn't it?
Well, yeah. I think in league they play nines, and nines it is a little bit thin. It's a little bit short of the grunt, but there's just, for my liking, too many guys on the field. And then you go to one of these video replays, and you hear these commentators discussing it like it's a matter of international criminal law in The Hague or something. Going, well, he was moving forward, but his arm was going in a backwards direction when it hit the ball that appears to have been bouncing backwards off a player who was in an offside position but not deliberately playing at the ball. What do the rules say, Gary? Of course the rules don't say fucking anything, because no one, it's like the founding fathers never conceived of that situation when the rules of the game were written. On TV... rugby league is amazing because it's so one-dimensional. Live, I find it really tedious. AFL on TV just can struggle a little bit because the ball can go anywhere from 15 centimetres to 60 metres in a 360-degree arc at any moment. So that's hard for the television to capture. AFL Live is just beautiful to watch.
Okay, I've heard that. I've never seen an AFL game live.
I've seen a couple live. They're amazing.
Okay.
What about short blokes, vertically challenged, I prefer to say? Like me, where do we fit in the AFL team?
You'd be a small crumbing forward, mate. Tom Papley from the Swans, who one of our key players, would be around, a bit fitter than you, a bit better looking, but...
that's not hard, though.
No, that doesn't narrow.
I can, probably a better lover too.
Yeah, around you. So there's room for very small players in football because the very big guys can't always grab the ball, and when it hits the ground, the very small guys pick it up a lot quicker than the very big guys.
Okay. And back to your latest book, which is
I was hoping we'd been 6 minutes without talking about it. It was going to be weird. It's called The Number Games, available at adamspencer.com.au. That website again, adamspencer.com.au, if you'd like a signed copy. Yes, that book. What about it?
Yes, that one. So your book has been praised by many critics, saying that it's kind of accessible for people of all ages. Maths is something that usually people struggle to convey to a variety of different age groups. How the hell did you manage that?
Well, I'm lucky. I'm lucky in two ways. One, I'm a brilliant and gifted communicator. But
Modesty again?
I'm lucky in that I get to cherry pick what I put in the book. So I'm just constantly seeing stuff in maths, and any time I say I follow a lot of different... There's some great stuff on Twitter. There's some great websites you can follow on Twitter that just publish maths all the time. There's some very nerdy maths websites on Twitter. But every maths problem or fact I see, the first thing that runs through the filter of my mind is, could I explain that to a reasonably smart 13-year-old? If I could, it's a real chance to go in the next book. So it's not quite to absolutely everyone. My stuff probably cuts in around 11 or 12 if you're pretty sharp and really like your maths, and from there up. So I'm lucky in that sense. And so I'm watching my daughter's in year 8 now, and watching some of the stuff that she's now starting to grapple with at high school, which is a piece of cake. Not hard, but it's not the most interesting stuff in the world, but you do sort of need those tools in the toolkit. I think the high school syllabus has got too much stuff in it for maths, just too much there. You'd be better off trimming a fair bit out of it and teaching it in more depth and teaching mathematical thought and problem solving and puzzling, and then you can just add on chunks of other things that you need if you ever do need it. A lot of kids at that sort of 2-unit level who are doing calculus are probably never going to use calculus in their life, and you could probably spend some of that time teaching them stuff a little bit more constructive that would be there with them all the time. So I'm lucky. I get to cherry pick stuff that does translate really beautifully and is fun and is a bit silly.
I often wonder how, like, science communicators like Neil deGrasse Tyson, Brian Cox, how they would go in a science classroom having to teach a curriculum saying you need to get through this.
No, exactly. And that's I go to schools now and then, and I just turn up for 45 minutes and jump around like a firecracker, have a great time, make everyone laugh, choose a particular thing I want to talk about that I know is really interesting, and then I piss off. Yeah. And leave the poor teachers for the other 219 teaching days.
The kids are sitting going, God, our teacher's boring. I wish we had a dispenser all the time.
Why doesn't they just crack jokes and teach us stuff that doesn't really exist in any greater framework than the 45 minutes they're here?
I've got your book at home. I've had a look. It's actually a lot of fun. So even if you don't have that mathematical ability, you can find stuff in there where you...
Biologist.
Yeah. So, but the philosophy of the books has always been half of the book, half of every one of them, there's 4 of them now, and half of it is numerical trivia that you don't need a mathematical bone in your body to understand. It's just bizarre stuff about the world that happens to do with numbers. And like I was just the other day was filming something for TV, and we gave a kid the watch. We were pretending we were setting up a kid as though he was living in the 1980s, and so I gifted him a Casio CA 53. Now the 53 is the calculator watch that Marty McFly wears in Back to the Future. So there's just something nerdy and funny, silly that happens to attach itself to the number 53. You don't have to know anything about numbers to understand that. And you can even get slightly mathematical things that you don't need any maths to understand. There's a great one in the latest book. There was a brilliant mathematician called Groening, I think German, brilliant mathematician from the 20th century. And one day he's walking along with another mathematician, as they do, and the mathematician, second guy's trying to explain to Groening some mathematical principle. And he said, look, let me give you an example. Look, just give me a prime number. And Groening went, okay, 51. And off the guy went for a couple of seconds. Then they realised that, well, actually 51's not prime. It's 3 lots of 17. So one of the greatest mathematicians of the 20th century had just thrown out 51 as a prime number when it's just clearly not. So it's now known affectionately as Groening's prime. Oh. Right? Because it's not prime, and it's one of the few mistakes that total mega brain ever made. So we hang that on him, and that's quite a cute little story that you don't need any maths at all.
That's incredible.
To understand. So half the book is just that. It's just that sort of bizarre trivia and fun. The other half is maths.
Yeah, great. Excellent.
So it is fun maths, though.
Yeah.
There's some word puzzles in there to do with it as well.
Yeah.
Back of your card, you had to find 5 different numbers in the words. That was pretty cool. I had a good time.
Thank you very much. Glad you enjoyed it. Did you find them?
I did. I found them. I think, what was it? 7, 3, 58...
And 40?
40, that was the other one. Well done, yeah.
Well done me. Well,
Yeah,
I did write the puzzle, so I'll take that.
Now, you've achieved many great things in your career.
Oh, yeah.
One of them is modesty.
Yep.
Appearing on Sci-gasm podcast.
Appearing on
this
podcast.
podcast.
Jeez.
Absolutely.
It's growing daily. Yeah. Firstly, I think one of your greatest achievements was hanging up live on air
on
talking
Lord Monkton.
to
Oh my God,
the
big fan.
full-time idiot Lord Monkton, who shouldn't even be called Lord.
I'd always liked you, Adam, but that was the moment I knew I loved you.
Oh, really? Yeah, that was. Yeah, you were. It wasn't universally well received. I wouldn't change it. It was fun day.
And the second, I was being approached by Matt Groening.
Yes.
How cool is that?
Now, he pronounces it graining, as in complaining, he says. It was beyond wonderful. I finished my TED talk on massive prime numbers, and I was out, I think that evening, and bumped into him. And he came up to me and said, really enjoyed your talk. And I suddenly thought, that's awesome. It's a really nice thing to say. Fuck, you look a little bit like, oh man, looked down at his name tag and it was him. And I was, and had a quick, lovely chat. And because all the head writers on The Simpsons are maths grads from Stanford and MIT and things like that. And so The Simpsons is loaded with mathematical jokes.
Yeah.
And in references and things like that. And he told me at the time, he said Simpsons is pretty nerdy. They would have loved it. He says, for the Futurama guys, they're ridiculous. They are total nerds. But the Simpsons stuff, there's great ones of, so you know Fermat's last theorem, that 3 squared plus 4 squared equals 5 squared. But Fermat said you'll never get numbers bigger than squares. You won't get something cubed plus something cubed equals something else cubed. There's no example of something to the 11 plus something to the 11 equals something else or anything like that. Squares is the only power for which that happens. And there's a great little cutaway once, but there's a couple of examples of numbers that come incredibly close. So a massive number to the 17 plus another massive number to the 17 equals another number to the 17. Well, actually, it's out by one or a couple or so, but it's remarkably close to finish. And there was a great cutaway once in The Simpsons in the reactor or something like that, and just for a split second, you just see Homer standing in front of a blackboard, and he's got that false solution to Fermat's last theorem just written up there, and he's just sort of scratching his head for a second, then it just cuts off.
Yeah.
I know I think The Simpsons, when Homer removed all the crayons from his brain and he wrote the proof for the non-existence of God, was actually predicting the weight of the Higgs boson.
Yeah, there you
before
go.
CERN did.
Yeah,
fantastic.
Yeah, and he there's a book by Simon Singh, the British, really good popular maths writer. He wrote a brilliant book on Fermat's last theorem. Everyone listening should read Singh's Fermat's last theorem. But he wrote a book called The Mathematical Secrets of The Simpsons that details all the different great maths jokes in The Simpsons.
Do you know him? We've been trying to get him on, actually. If you put in a good word for us, we'd appreciate that.
I do know. I vaguely know Simon. Yeah, I did work with him several years ago. Lovely guy.
Excellent. All right, well, we'll hassle him a bit more. Maybe we can get him on. Yeah, we can just talk Simpsons for half an hour as well.
Judge on the 15 minutes I've had so far, I could only recommend it in the John Cleese sense.
Like cheese.
Like cheese.
Exactly.
What's next on the horizon for you?
In the very short term, I'm helping my girlfriend move apartments.
Which you're thoroughly enjoying?
I'm loving every second of it. The poor thing's recently got a massive new job promotion. This incredible, full-on, but great job. She's got the flu as we speak, and we've got to move apartments, and she's just found out there's a little bit at the... We've just found out that we've gone... So we're within the same block, so it's just up on a few levels up from where we are. So we popped up there today with the keys, all excited. Whole place hasn't been cleaned or inspected properly or anything. And there's what looks a hell of a lot like a fridge and a washing machine still in this place that we were pretty sure were being removed because it was advertised and the lease says unfurnished. The move house is a little bit stressful, so that's my immediate short term.
But I'm very short term.
Not far away from thinking about the next book.
Great.
And starting the process sort of has to. We have to. Oh well, I've been compiling all the stuff, and I've got to start trying to get that into a bit of a logical order. I've got an awesome name for the next book, suggested by John, who's just downstairs. John, are you still there?
John just ducked out.
He's ducked out. I probably shouldn't put Roy... I shouldn't say publicly into a microphone what the name of the next book's going to be, should I?
We can bleep it out for you if you want. Just...
yeah, it's a really... awesome idea for a name.
This is a great cliffhanger.
So I've got to be. I think it's such a good idea for a name that if I told you, there's a real chance someone else would copy it.
Okay.
Oh wow!
Yeah, it's that good.
You're pumping out some books. You're chasing down Dr. Karl by the sounds of things.
One a year. Well, no, he's ahead by about 34. And
you've got time on your side though.
He keeps going at one a year with the occasional extra. So something would have to befall Dr. Karl for me to catch him in the number of books, and I don't wish that upon him. I'm not willing to admit on digital recording that I would wish that upon him or actively be planning it in any way.
Well, you've done a lot of stuff.
I do know where he shops, and there's this line of sight from a building above down, and then there's a stairwell you could get out through a back lane, and you'd be gone before he even hit. Sorry.
You've done a lot of stuff with Dr. Karl.
Yeah, we've worked together for a long time.
Yeah, we've interviewed him once. I think it was once. We've caught up with him a few times.
Once that we've kept on recording, yeah.
Yeah, once that we kept on recording. He's such a lovely guy.
Great bloke.
You guys did a podcast together.
We did.
That was rather successful,
Sleek
wasn't it?
Geeks was going all right. Yeah,
TV show.
Yeah.
It was fantastic.
Yeah, it was fun. We did 2 series of the TV show, which was ridiculously hard work. And yeah, not supported by a tremendous amount of resources.
Yeah, how much better is it podcasting where you board shorts and your thongs and just roll in whenever you want?
Yeah, but there was something like that. We did some, with Ruben Mim and the surfing scientist helping us, he cracked a concrete block on my stomach while I was lying on a bed of nails.
Oh.
And that was great fun. And we did some fire walking, and we created probably my favourite thing we did in all the series. We created a giant tub of a liquid. Most fluids, the more you agitate them, the more they break up, and more likely something would sink in them or something like that. But non-Newtonian fluids, the more you stir them, the thicker and more solid they become. And so if you make up, I think it's cornstarch,
it is cornstarch,
and water en masse, and you can run across it. It's a liquid. But if you run fast enough, you just bounce across. It's like running on a trampoline. Like if you ran on, like a pool cover. It's like you're running on a pool with a pool cover on it. So but you can run end to end on this liquid,
like a water strider or a Jesus lizard.
If you stand still, you'll sink into it. And we made a big tub of that. And so we're filming this TV show, and while these guys are over there mixing the stuff, because if they stop for too long, it's going to set and all this. So they're slowly mixing, and it takes 4 to 4.5 hours to have this stuff ready. So we have to start it 2 hours before we start shooting the show, because that's probably how long it'll take with all the... It was just so stressful. But it finishes with us running up and down that. It was just awesome.
That sounds like a lot of fun, actually.
It was so good.
Have you ever seen Super Cooled Helium?
No.
that turns into a liquid, and it just does some really strange shit.
Yeah.
It like goes up the beaker, the side of the beaker, and goes over the edge.
Because how cold would that have to get to set?
It's almost absolute.
I was going to say it's minus 270 or something.
It's almost right near absolute zero. I think it's 2 Kelvin or something stupid like that. It does all this weird shit. It's crazy.
You would think so when it's that cold. Yeah, it's not going to behave normally.
No, it's not.
That was one of the great... I never knew this, in fact, in my last book, that with water, so when water freezes, it's not that the entire glass of water goes from entirely liquid to every atom of it frozen instantly. The freezing has to start somewhere. And in normal tap water that's dirty and might have air bubbles in it and things like that, those impurities are the spots where the freezing begins. They're called nucleation centres. So a bit of freezing will start. If you get a glass of water that's just starting to freeze, there's like really thin little strip. Those tend to start at like a piece of dust or something and then build out until the whole thing's eventually frozen. So if you have perfectly pure water sitting perfectly still, so there's no wobbling inside or air bubbles or anything like that, you can slowly lower the temperature of water to minus 42 degrees.
Wow.
Before it has no choice but to freeze.
Wow.
Minus 42.
When it gets to 42, does it still have the nucleation thing going on?
No, I don't know if it then happens everywhere instantly, but I know if you get it down to like minus 20 and then drop something, agitate it, it just all instantly freezes.
That's cool.
And so that's when you get explosive freezing. So if you had it in a glass and cooled it really slowly to minus 20 and drop something into it, I think the glass all just shatters.
Have you ever seen when you cool a bottle of water in the freezer, like Fiji water or something like that, and you get it out gently and you go bang and you hit it on the table and it all turns to ice? Veritasium did that one of his videos. Right?
Yeah, and you've done the same thing there. I think you've got below zero or sufficiently close that you then create all these nucleation centres. Yeah. And the water just instantly, yeah.
Well, that's my weekend taken care of.
Done.
Fantastic.
I'll be lugging a washing machine up a flight of stairs, and you'll be.
Byrne's really good at lifting heavy stuff.
Freezing Fiji water.
Actually, we might be taking a washing machine down the stairs too.
Yes,
right.
indeed.
Lower to the ground. It's easy for me to pick stuff up.
Small crumbing forward and removalist.
Yeah, that's right. Now, you're most famous, I dare say, with the whole maths numbers thing, with the really big prime numbers, those huge numbers.
Sure.
How big do numbers get before we're really starting to make stuff up?
That's a good question. How big numbers get before they lack any practical application, or much
that would be a nerd way to
application?
put it. Yeah, sounds a lot smarter than the way I put it, doesn't it? Yeah. So fundamental particles, when you get down below electrons and all that to the bits that make up electrons, the number of fundamental particles in the entire observable universe, most of the estimates I've seen of that are somewhere between an 80 to 85 digit long number. So something beyond 85 digits long is bigger than the number of bits of everything there are, bits of anything there are in everything. So how often you need a number bigger than that? Probably not very much.
Multiverse theory.
Yep, but a really cute flip side of that is also how small or precise do numbers need to be before you don't need to bother anymore. So, people have learnt pi to 100 decimal places and 1,000 decimal places, and we've calculated it to 12 trillion decimal places.
Oh my gosh.
When NASA is landing a probe on a comet in space, which is fairly technical, how many decimal places do you think NASA takes pi to?
Oh,
I'm going to go with 7 because it's a lucky number. What do you
3.
reckon?
15.
15?
Beyond 15, there's no practical accuracy improvement.
It's still not very much,
across
though.
the vast.
Jeez, we better not launch anything on an asteroid.
Oh, yeah.
You didn't know that already? Yeah.
But even like your 22/7 measurement of pi is remarkably accurate for the vast bulk of practical applications.
Yeah, we were interviewing Geraint Lewis, Professor Geraint Lewis,
yes.
an astrophysicist.
Yeah.
And he was saying that you can get Einstein's general relativity is correct in the movement of celestial objects to like something like 8 decimal places or something like that, which is incredible. Yeah. It's incredibly accurate. It's the most amazing thing I've ever heard. It's like yet we still can't link it, the really big to the really small.
Yep.
It's
a disconnect.
Quantum mechanics is so accurate in its predictions as well. So there's these two things that just don't go along, but as we know, that they follow two different kind of... They're both explained by mathematics.
But where the grey zone is between them is quite amazing. Another interesting concept someone explained to me once is that with quantum, if you're trying to build a quantum computer, I'll just say there are 8 components to this computer that have to be all clicked together. Now, each of those components might work within the quantum dimensions, but perhaps just clicking all 8 of them together creates a device of a sufficient size that the quantum all just breaks down and it won't work. Even though all the individual components do. Now, if that's the case, that's pretty full-on and quite challenging for if you're ever going to be able to build a quantum computer. But it also, then, you'll learn something really interesting about the quantum world and the quantum state just from the failure of that device to work. And the other one I really like is when people talk about AI and, whether the robot overlords will, and there's obviously, one conceivable way that AI could be a problem would be if machines were ever deliberately hostile to us in your Terminator scenario and all that. But another way is just if machines, if a coherent intelligence just, they call it the alignment problem, if its goals don't align with what human goals are. So then it's often, the metaphor that's used is paperclips, and if it just decides that what's important is to build the perfect paperclip and starts dedicating all of its thought, that doesn't help us very much if it's meant to be running health systems and things like that. But the other great one I asked, someone suggested to me once, was just imagine if the AI thing comes and one computer manages to convince all the other computers and systems in the world, what we really need to... This number pi, we've only got it to 12 trillion decimal places. Guys, I want you all to now just give everything you've got. Let's just crunch this fucker as far as we can. And if the AI systems that are meant to be running health systems and keeping aeroplanes in the air and driverless cars and all that, just go, no, we're taking Sunday off to calculate pi, we are rooted.
We've got to work out this ratio here.
Yeah.
Do you think, like, being a mathematician, will we ever find pi to a certain kind of point? Like, where we
Mate,
can...
are you not happy with 12 trillion or something? What's your problem?
No, we know that it doesn't end. It goes forever.
It doesn't end, okay.
We know that it's irrational.
Yeah, okay.
No, it goes forever. It can't be expressed as a fraction. We know it's transcendental, which means it can't be... So something like the square root of 2 goes on forever, but you can write an equation, a polynomial, using only whole numbers as your variables, that square root of 2 is the answer to. You can write x squared minus 2 equals 0. Now, the answer to that is the square root of 2, or negative square root of 2. Those decimals go on forever. So that's an infinite, non-repeating decimal expansion, but there's still an algebraic statement to which it's the solution. Numbers that they can't do that for are called transcendental. So pi does not come about as the solution to any integered polynomial equation.
What about E?
E is also transcendental.
Oh, cool. Yeah, I know two.
But there's
transcendental.
He's talking about the drug.
Yeah, but the thing is that while those numbers seem rarities to us because they're the last ones we learn the whole numbers, then we learn fractions, then we learn negative numbers, then we eventually get to the square root of 2, blah, blah, blah. Then we eventually think, wow, floating out there's a small number of these really weird infinite, blah, blah, blah. In the infinity of numbers, if you had the infinity of numbers in a bag and you put your hand in and drew one out, you would draw out an infinite, non-repeating, irrational.
Oh, okay,
they are the overwhelming bulk of the numbers.
Wow, I had no idea.
Yeah. You would be dipping your hand in there forever before you pulled out a fraction.
Wow.
Or anything like that. Yeah,
or a whole number.
Yeah, they're the over... Oh, yeah, you would never pull out a whole number.
Really?
No, but think about
they're
how
infinite.
Many... but think about how many think about how many numbers there are in between 1 and 2 compared to,
Infinite. That blows my mind, doesn't it?
Yeah.
Infinite numbers
well,
at every scale.
I'll leave you with this one. This is great then about infinite numbers. Some infinities are bigger than others. Right? So you've got the whole numbers are infinite, but we call them countably infinite because I can write a list and you can challenge me. Oh, yeah, right. Are you sure number 61 is on your list? Yeah, it is, dickhead. It's in the 61st position. Oh, okay. What about 37? Oh, fuck, mate, it's back there. Yeah, the obvious, right? The fractions. A brilliant mathematician called Cantor
worked out there's a way you could order the fractions so that they're also countable. And it's not that hard. If you consider every fraction, put them in the group of what the numerator and denominator add up to. So 2 over 7, which adds up to 9, would be in the same group as 3 over 6 and 5 over 4 and all that, because they all add up to 9, yeah? So now how do we order those? Well, let's start with 0 on the top, so 0 over 9, then 1 over 8, 2 over 7, 3 over... So there's a logical way we could order all of those. So I can then produce a list of fractions. And when you say to me, well, is 51 on 126 on your list? Yeah, it is. It's going to be in group 51 plus 126. It's going to be in group 177. It's going to be the 52nd thing along, should start with a 0. So you can order the fractions in a logical way that you are confident every fraction is on that list. So it's countably infinite. Wow. So the size of the infinity of fractions is the same size as the infinity of whole numbers. I could write my list, you could write your list next together, and we could draw an arrow between everything, and we're confident that the numbers 1, 2, 3, 4, 5 line up with 0 over 1, 0 over 2, 1 over 1, 2 over 0, blah, 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 blah. But when we go to our irrational numbers, where after the decimal place you can keep going forever. If you say to me, I've managed to write a list of those two that are in an order and they're all on the list, I know for a fact I can write down a number that's not on your list. I can challenge you with a number that I know is not there. And the way I would do it, I'd look at your list, I'd look at the first number on your list, and my new number, I would just pick a different first digit to your number. So I know my number is not the first number on your list. I'd go to the second number on your list, I would look at its second digit. I would give my number a different second digit. So I know my number is not the first number on your list, and it's not the second number on your list because it's different in that first or second digit. When I get down to the 458th number on your list, I would just make sure that my new number had a different 458th position, digit. Now, if your 458th number was just the number 7, well, I'd be going after the zeros on mine or whatever, but I know that my number's got a different to yours.
Yeah, and you can write down an infinite number of them as well.
I just keep going. And I know that my number there does not appear on your list anywhere. So the irrationals are uncountably infinite. It's a bigger infinity than the infinity of counting numbers.
That's crazy.
It's awesome.
So many infinities, right?
That's so awesome.
Then a really deep question becomes, are there infinities of a size in between those two? Are there a continuum of infinities?
Spectrum of infinities.
Yeah, and that it's called the continuum hypothesis. Cantor, who I talked about, who did the fractions, literally went mad studying the continuum hypothesis.
As you would.
So to anyone
feel
listening,
like I'm losing my mind a little bit now.
Yeah, you might want to just stop at how far I've taken you down that path.
Otherwise you'll end up losing.
And back away slowly. Yeah, but I love that.
End up heading down the hall and getting infinity tattooed on you.
Exactly. Now that
there's a tattoo parlor just down. Let's all go down and get matching infinity tattoos.
I think I explained that in my second book, The World of Numbers, which is available at adamspencer.com.au. You can get an autographed copy of The World of Numbers. On my first book, The Big Book of Numbers. On my third book, Time Machine. My fourth book, The Number Games. And as of November this year, my fifth book, yet to be named, at adamspencer.com.au.
Excellent.
Fantastic. Adam, thank you very much for your time today.
Thanks, mate.
Pleasure, guys.